Hi, and welcome back. So in the last video, we were taking a look at this function f of x, and we defined f of x as a set of different functions. And it was very similar to the last video where we said that from x is greater than minus infinity right up until x is equal to 0. So for all values up to but not including 0, x was going to be equal to minus x. And we found out that if we approached that the limit as we approached x from the negative side was going to be equal to 0. And importantly, what I guess the most important thing that we covered in the last video is that we discussed this notation of saying as x approaches 0 only from the negative side, only from the left side of our graph, that was going to be equal to 0 in this particular example. And that also, if we approach 0 from the positive side of our graph, that was going to be equal to negative 2, because at that point, or for all values of x greater than 0, our function was going to be defined as this function, as x squared minus 2. And if we the limit of this function as we approached it from the positive side was going to be negative 2. Now, what I want to ask in this question, or what I want to ask in this video, or the first question I want to ask, and it's going to hopefully lead to a little bit of an intuition about what we're really asking for when we take the two-sided limit of these functions. If you can tell, these are called one-sided limits. Let me actually write that down. Choose a good color. So these two limits right here, because we have these conditions, these are called one-sided or single-sided limits. And that, if you remember from the first couple of videos that we did, or that I had in this playlist, those are different from what we normally had. Normally, we would have the limit just as x approached, I'll just call it some value a, of some function, I'll call it g of x here. And we didn't have a condition up there. And so you might ask, well, what does that mean? What does it mean that we didn't have a condition there and that we do have a condition here? Or how can we deduce what this limit would be as x approached one value from these two, or how could we deduce what the double-sided limit would be? And that's typically what what you would call this, or I don't know if you were referring to it in terms of in the context of dealing with single-sided or one-sided limits, you might call this a double-sided limit. Typically this is just called the limit, I guess. But if you were asking, well, what would this equal if we were going to say, let me just erase that g of x, if we were going to say, what is the limit as x approaches 0 of our function f of x in this particular example? What can we say about it? If we were going to just use this information, the limit as x approaches 0 from the negative side was equal to 0, and the limit as x approached 0 from the positive side was equal to negative 2. What we can say about that when we deal with, I guess, the double-sided limit, or just the regular limit that we've seen over the past couple of videos, we can say that if these two limits aren't equal, if we approach a different number, if we approach from the left than we would if we approach from a right, we can say that this limit of f of x as x approaches 0 does not exist. And that's how you're going to notate it on your homework or on a test, or maybe you won't. Maybe you should ask your teacher about how you should write that down. Typically, this is how that's written down. If one side, if you approach a different number, if you approach one number as you approach from the left and you approach a different number as you approach from the right, then the overall limit, the double-sided limit as your function approaches 0, or as the value of x approaches 0, does not exist. So let me actually just go ahead and I'll maybe create, actually Yeah, maybe I'll just go over here and write that down. Or else, actually, you know what? I'm going to be going down here anyway. So let me just write that down real quick just to drill that in. Star it. So if the limit as x approaches c from the negative side of, let's just call it g of x, does not equal the limit as x approaches c from the positive side of g of x, then the limit as x approaches c, and I'm not going to put any condition, I'm just going to say the limit as x approaches c, and that means that as we approach c from either side, of the function g of x does not exist. So anyway, that is pretty much the big takeaway for this video. And actually what I'm going to do now, let me actually get some more space over here. There, that'll be good. And let me actually go back to, if you remember the first, the function that we defined, I guess 2 videos ago. We said that f of x was going to be equal to, we say it was negative x for minus infinity less than x less than 0. Sorry, I'm going to go a little fast. And then it was going to be equal to 2 on 2. Actually, let me just say 2 is equal to x. And then we were going to say that it was equal to x squared for 0 was less than x, which was less than infinity. So then I'm just going to draw this really quick. We had our open graph right there, and we had our parabola like that. And then we had our line with the slope of -1 coming in, and we were undefined at the origin. And then we had our point right here at x is equal to 0, y is equal to 2. And so now let me ask you, what is the limit as x approaches 0 from the negative side of this function f of x? And hopefully you can see it's the exact same thing that we've done in the past bunch of videos actually. Just we choose values that are closer and closer to 0, and we can see that this function, as we get really close to 0 from only the negative side, that this is going to be equal to 0. Then I'm going to ask you, what is the limit as x approaches 0 from the positive side of this function f of x? And again, you're going to choose closer and closer values, and that's a really sorry looking parabola, I guess. I don't know if I'm going to be able to do much better, but anyway, sorry. Anyway, you're going to choose values that are closer and closer to 0 on this, only on this positive side, only values that are just a little bit greater than 0 over here. And you're going to try to find values that are closer and closer to 0 from this side of, on this side of the graph. And hopefully you can see again that this is going to be equal to 0. And so now the big takeaway for this video, we can see that the limit as x approaches 0 of f of x from the negative side is equal to the limit as x approaches 0 from the positive side of f of x, which means, I'll just say that, which means that the limit as x approaches 0 from both sides of f of x, that it exists, and it's also going to be equal to what each of these guys are equal to. And actually, you know what, I'll just say it's equal to the limit as f of x approaches 0, which is equal to 0. So anyway, hopefully that gave you a little bit of intuition on this video. The big things I wanted you to take away were that when both of these limits exist, when both as f of x approaches 0 from the negative side and from the positive side exist, and they're equal to each other, that is when the limit as f of x approaches some value, or in this case approaches 0, is going to be defined or is going to exist. And they're all going to be equal to each other. They're all going to be equal to the same thing. But if one of those, if the limit of one side does not equal the limit of the other side, then the double-sided limit, then the limit as x approaches whatever that constant is from either side does not exist. So anyway, hopefully you found that helpful. And in the next video, I can't decide if I should. Oh, you know what? In the next video, I'm going to start doing some examples of different functions. So anyway, hopefully you found that useful, and I'll see you in a future video.